Welcome to this series on internal assessment. What I'm doing here is I'm trying to answer all these questions. If you go to the forum, you're going to see that there's heaps and heaps of questions. So if you go to IB Survival and you go down and look at what are the questions all about here. IA guide, failed results from my IA, Chemistry IA, what defines an IA. You can see that by far the biggest questions that students have are to do with internal assessment, and even if you go to the special website that only IB teachers have access to, you get the same thing. Even the teachers are asking IA. So what I've decided to do is show what I do for IAs. I'm just going to go to my Google Classroom and I'm going to just pull up the IAs from my students and just show you where I'm at. Now these resources here I'll make available on my website. I'll just put them there. I'll put the links to that in the description. And this template especially, IB doesn't like templates or checklists, but I have had this checked by a very experienced IB internal assessment examiner. We've gone through this and these are really the main things that you need to get, and I'll be working my way back to this quite often. So I'm going to put some anonymous reports out there. I'm hoping that all of you will watch it, and I'm talking to my students here. I'm putting them up anonymously. You're going to have to go and look at each other's and get good pointers from each other like I normally do in class. Okay, so this experiment's looking for the glucose concentration in drinks. Introduction needs to be cleaned up a little bit. I can't see a photo of what it looked like, especially the colors. I'm glad you got this here. So what am I doing here? I'm getting a purple to a colorless. Where's the glucose in this, and what's that doing? So is the glucose getting oxidized or reduced? Where's all the chemistry in that? And what about the other sugars? Are they interfering? You've got to think. You've got to have all this in your design, and you've got to account for it. Maybe had a positive, negative controls for interfering sugars. So this has gone ahead now, but even though you haven't done it in your design, you can always make up for it by covering it in your introduction. And it is only an IA, so maybe it's not within reason that you can do it that well, and that's part of your justification for not doing all these extra things, because it's only meant to take 10 hours. So I can't see a photo in here. I can't see this safety. How do I know? Where's that reference from? Go to Cleeps. You can fix up your full referencing later. This is really messy. Where am I going with this? Eek. Alright, that needs to be referenced. Did you draw that yourself? I'm not sure. If you did, you still write it. Okay, say I drew that myself. Otherwise, it's plagiarism, so get that fixed up. You really need to fix this up. If I'm going to go through it and try and correct it, I kind of need to see what's legit and what's not. This is just sort of a mess. So you could spend a fair amount of time making this as if you're going to hand it in, even though it's nowhere near ready to hand in. Where are we going here? This is very repetitive. Oh, here we go. That looks better. We've got highlighting. Interesting. At least you've done this. People are putting me the solutions, giving me and not telling me what they are. But you haven't told me the percentage on that. So you can still fix that up. Go to in the top right hand corner right now, I've got a set of 4 titration videos that show how to do the titration calculations, and the first one shows you the bottle with all the errors on it. But I did tell everyone to take pictures of the bottles of their reagents, because that's relevant too. This is probably 99% or worse. So let's look at that. I think this has become a distraction, because it's more important to measure the temperature inside the reaction vessel. This is relevant for different types of labs, but anyway, okay, you've done this. This is nice. Right, you've put a lot of work into it, which is good. Just keep your units IB. Okay. Alright, so how much time have I spent? God, I spent a couple of minutes just working out where your lab is. So, trial 1, 2, 3, 4, 5, 6. Got various glucose solutions. and various concentrations. I need to see how they're made up, and you've got this here that's gone colorless, so that's not that helpful. Oh, that's red to start with, right? I still don't know what's going on here. Which one's getting oxidized, which one's getting reduced and stuff. Alright, I'll be nice on you for that, because we'll wait till topic 9's being taught, and then you can fill all that in nicely. So we'll just leave that for the time being. See, I love these photos. What's all this bubbling stuff here? Alright, I hope you've put that in your qualitative observations underneath your quantitative and explained that. Alright, I just stopped the video then to put these black boxes in. So it's gone yellowish. Alright, I'll have to deal with that later. Alright, this is mainly to see if you finish your experiments. So let's have a look at these. You've got discontinuous data here. Biology students love discontinuous data, and the physics. If you're either doing biology and chem or physics and chem, and it's really quite obvious all the time actually. So these are biology students. So time to decolorize. How did you get that? Go check that out. Go ask one of the physics students on what's the standard for stopwatch. And so here's your data. It doesn't really match your uncertainty. If it really was plus or minus 1, you'd be going 33 and 42. And that's really messy. I don't need to see how you did the mean. Just give me what it is. So you've got three things. You've done a repetition of 3 or 4. Okay, so that's a decent range. It would have been better to go to the 5, but that's okay. I hope the examiner think that's okay. And so that's time to decolorize, and as it's getting more and more concentrated, it's taking. Alright, so if it's really concentrated, it's not taking much time to decolorize. That's a little strange. You would expect reactions to be like this, and so as the concentration gets really weak, it slows down and takes ages to decolorize. So that needs a little bit of interpretation and explanation. Alright, that there is brilliant for your error analysis, but that's not a qualitative. So you need to talk on that, expand on that. But that's not your qualitative observations. Okay, so looking at your graph here, time to decolorize, concentration of glucose. So as I said before, I'd like to see the annotations of like the Red Bull or whatever. I need more grid lines in there. What's going on here? Your plus or minuses. Oh, it's changed to, oh no, it's gone to 1 now. So make sure that's correct. Now I know this does make sense somehow, because I've had it. She explained it to me once, and yeah, it made sense. And then a little later, I was confused on it. She explained it to me again, and yeah, it makes sense. It does actually make sense. I know it does. I just don't know how. So can you put a paragraph in your introduction that clearly explains, maybe with a diagram, so it stands out, and explain how that works. Because it's number 3 and I've forgotten again. So explain how that whole thing works, please. And discussion. I think you're ready to move on to that. So go on to the user table to discuss it. Clean up some of the clarity. But the main point is you've finished your experiment, so that's good. If you found that helpful, please like it and put some comments in the comments below, and please check out the other videos for more advice.